Hello, today we are going to learn alternating series. In this section, we are going to learn one theorem. That theorem helps you to do or compute the solutions of alternating series. First of all, let's understand what does it mean by an alternating series. An alternating series is a series whose terms are alternatively positive and negative. Or let's discuss examples. I have two examples here. The first example is sigma n goes from 1 to infinity minus 1 to the power n minus 1 over n. If you expand this, the series will be like this. First it is negative 1 to the power 0 over n, which is 1, then plus negative 1 to the power 2 minus 1 is 1 over 2 plus negative 1 to the power 2 over 3 plus negative 1 to the power 3 over 4. So these are the first four terms of the series. Let me expand this. Minus 1 to the power 0 is 1. So the first term is just 1 plus minus 1 to the power 1 is negative 1 over 2. That means negative half. Then negative 1 to the power 2 is just positive 1. So that this term is 1 over 3. And then negative 1 to the power 3 is negative 1 over 4. Okay, so these are the terms of this series, the first four terms. And write the next series, which is B, sigma n goes from 1 to infinity minus 1 to the power n over n plus 1. First term is minus 1 to the power 1 over 1 plus 1 plus minus 1 to the power 2 over 2 plus 1 minus 1 to the power 3 over 3 plus 1 and minus 1 to the power 4 times 4 over 4 plus 1 and blah blah blah. So let me simplify this. This is minus 1 to the power 1 is minus 1 over 2 and then this is minus 1 to the power 2 is plus 1 and then this is 2 over 3 and here minus 1 to the power 3 is minus, here 3 over 3 plus 1 is 3 over 4 and finally it is plus 4 over 5. Okay, so those are the first four terms of the next series. Alright, so I wrote two alternating series. You can understand why they are called alternating series because the sign changes. It goes like either positive, negative, either goes like positive, negative, negative, positive, and positive, negative, or maybe negative, positive, positive, negative, and negative, positive. Okay, the sign changes. So these are called alternating series. Now let's learn the theorem. This theorem is called alternating series test. Let's learn alternating series test. Alright, first of all, I just discussed two cases. If an alternating series, case 1, let's say you have something like sigma n goes from 1 to infinity minus 1 to the power n minus 1 times bn. This can be expanded as bn minus it is b1 minus b2 plus b3 minus b4 plus bn greater than 0. And in case 2, sigma n goes from 1 to infinity minus 1 to the power n bn, and then this expansion of this one is minus b1 plus b2 minus b3 plus b4 plus, sorry, this is negative. And here also bn is positive. There are two cases, all right. In the first case, the first series start with positive. The second case, the series start with negative. All right. So those are the two cases. Case 1, case 2. This positive negative case. All right. Right. Then the theorem comes. This series should satisfy 1. You should have bn greater than or equal to bn plus 1 for all n. Alright, what's the meaning of this? Bn should be greater than or equal to bn plus 1. That is, this is a decreasing series. Okay, this is a decreasing series. Okay, then 2, limit n goes to infinity, bn goes to 0. That means the nth term goes to 0 when n goes to infinity. Okay, the conclusion is this. The alternating series convergent. Then the then the alternating series converges. All right, so let's discuss the the second example. Let's say you are given this series, sigma n goes from 1 to infinity minus 1 to the power n minus 1 over n. Alright, so first of all we have to understand what is Bn. So you can write this the same problem like sigma. Let me write it in the next line. You can write the same problem as sigma n goes from 1 to infinity. I just separate minus 1 to the power n minus 1 and then I write 1 over n. Okay, so this is the alternating part, the alternating sign part. This alternates. Okay, this part alternates sign, and this is actually Bn. Okay, now you understood what Bn is. That is Bn equals 1 over n. Alright, then you have to check these two conditions. First you have to check whether Bn decreases, and then you have to check whether when n goes to infinity, Bn goes to 0. Okay, you have to check these two conditions. The first condition, you know Bn is 1 over n, and you know 1 over n is greater than 1 over n plus 1. Okay, that is straightforward. 1 over n is greater than 1 over n plus 1. 1 over n plus 1 is actually Bn plus 1. Okay, so this implies Bn is greater than Bn plus 1. Okay, the first condition is satisfied. Okay, this is for all n. That is Bn decreases. Now go to the second point. Limit n goes to infinity, you have to check this quantity. Limit n goes to infinity Bn, which is also equal to limit n goes to infinity 1 over n, which is 0. Okay, so both conditions are satisfied. The first condition is checked, second condition is checked. These are the two conditions, 1 check, 2 check. That means the series is convergent. The conclusion is this: it is convergent. Thus, the series is convergent. Alright, the series is convergent. Now let's discuss the third example. In the third example, you have to find sigma. N goes from 1 to infinity. Minus 1 to the power n, 3n over 4n minus 1. Alright. So you can understand this alternate the sign. And this is actually Bn. Alright, your Bn should be 3n over 4n minus 1. The first thing that you have to check with is Bn decreases or not. Does Bn decrease? Alright. For that, how do you check it? So you could just use the first derivative that you have learned in Calc 1. You consider, you take a function that represents this case, this Bn. Take a function that represents Bn, that is, consider f of x that exactly represent this function, that is 3x over 4x minus 1. Okay, you take that function which represents the given bn. All right, and then you just get the derivative of f of x, f prime x, the derivative. You compute the derivative because you're going to compute whether it is decreasing or not. First compute the derivative and then check whether the derivative is negative. If the derivative is negative, then the function decreases. So you just compute f prime x. For that, first you have to, the derivative rule here is the quotient rule for derivatives. Okay, as you remember, let me write that here. The quotient rule goes like this: d f over g. If you have something like this is actually g is square g df over, let me write like this, g times f prime minus f times g prime. Okay, so this is the formula that we are going to use. Okay, so we are going to use that formula. So you write 4x minus 1 square of that, and then you write 4x minus 1 and the derivative of 3x. Then you just write 3x and then you get the derivative of the other function, which is 4x minus 1. Alright, so this will be 4x minus 1, the derivative of 3x is 3, then you write 3x, derivative of 4 times x is just 4, divided by 4x minus 1 square. So this is actually 12x minus 3 minus 12x. You can cancel this 12x with that 12x, and then I forgot to write the denominator. The denominator is 4x minus 1 square, and then this is minus 3 over 4x minus 1 square. You can see this is negative, alright, because it has a negative sign in front, and then this is a square, so it never be negative. Because of that reason, f prime x is negative. Alright, f prime x is negative. That means the conclusion is bn decreases. This bn decreases because the derivative was negative. Since f prime of x is negative, f of x decreases. That is bn decreases. Alright, now the first point is checked. You have just proved that bn decreases. Now you have to show that bn goes to 0 when n goes to infinity. That is 1, this is 2. In 2, you have to compute the limit n goes to infinity bn, which is the limit n goes to infinity. Bn is actually 3n over 4n minus 1. So you have learned limits in Calc 1. You can use that knowledge here. So this can be written down as limit n goes to infinity. Now you divide the numerator and the denominator by the highest power of n. The highest power of n is n into the power 1, which is n. So you divide the numerator and denominator by that. If you divide that means this is what you are doing. So this equals n goes to infinity 3 over 4 minus 1 over n. Then you apply the limit. What you get is 3 over 4. But this does not equal to 0. Okay, that's a problem. This does not equal to 0. Why that's a problem? Go to the theorem. You should show that the theorem. You should show that this limit should be 0. You should show that this limit should be 0. But unfortunately, we had that limit to be 3 over 4, which is not 0. Okay, which is not 0. Okay, so this means it's a contradiction. So it does not satisfy the second condition. Since the second condition is not satisfied, the alternating test fails. Alternating series test fails. Alright, so keep that in mind. It fails. Now you can't use alternating series test, but you have to show this is convergent to divergent. Okay, since the alternating series test fails, you could use some other method. So far you have learned a lot of methods to show whether the series is convergent or divergent. Alright, next what I'm going to use is n-term test that you learn very early in this chapter. Okay, let's use an n-term test. Okay, so you are going to use the n-term test. Let's write down the n-term test. N-term test says if limit n goes to infinity, an does not equal to 0, then this series n goes from 1 to infinity diverges. Okay, it says this diverges. Alright, now just work on this problem. Let's find what is an now. Our an should be this entire thing. This entire thing is our an. Okay, including this negative parts. That means alternating parts, including the alternating parts. Our an should be minus 1 to the power n 3n over 4n minus 1. Now just consider the limit that 3n over 4n minus 1. Now you just divide the numerator and denominator by the highest power of n. So you write negative 1 to the power n. Then you do this trick that you learn in Calc 1. You learn limits in Calc 1, alright? So you have done this part in Calc 1. So you divide numerator and denominator by n. And then this is 3 over 4 minus 1 over n. Alright, now you have to find the limits of this. Alright, how do you find the limits of this? When n goes to infinity, this is of course 0. This part of course 0, and this part either negative or positive. Okay, this is always negative or negative 1 or positive 1. But this part goes to 0 when n goes to infinity. This goes to 0 when n goes to infinity. That means the answer here should be negative 3 over 4 or positive 3 over 4. Okay, this limit should be negative 3 over 4 or positive 3 over 4. Okay, so either negative 3 over 4 or positive 3 over 4 does not equal to 0. Either of them does not equal to 0. Okay, they are not 0. Alright, they are not 0. That means by using the n-term test, if this an does not go to 0, then the series diverges. This an does not go to 0. That's what happened here. It doesn't go to 0. It is either 3 over 4 or negative 3 over 4, positive 3 over 4, negative 3 over 4. Then the series diverges. Alright, so that is the conclusion. Then the conclusion is by the n-term test, the given series, which is n goes from 1 to infinity minus 1 to the power n, 3n over 4n minus 1 is is divergent. Alright, so that is the end of the section. Here we discussed two good problems and one introductory level problem. So the first problem we discuss is right here, where we learn what are the alternating series. Okay, that's the first problem we discuss. And thereafter, we discuss a good problem where we use alternating series. And then we use the third example, which is even more important. The reason for that is third example shows a case where alternating series does not applicable. Okay, see, alternating series does not applicable. So if it's does not applicable, then you have to use a different method. Here I use the n-term test. So that is the end of the section. Thank you.